Imagine you have been a plumber for like 30 years.
Okay.
You know exactly what a normal clog looks like, right? You've cleared thousands of them. But then one day, you pull a solid 3-foot-long rubbery white cast out of a pipe,
Oh, wow.
and it perfectly mimics the shape of the plumbing itself, complete with the little branches where the pipe split.
Right, the bifurcations.
Yeah. Now imagine that pipe isn't under a kitchen sink. It is the femoral artery of a human being.
It is a profoundly unsettling image, but it really captures the exact mechanical reality of what we are analyzing today.
Yeah, welcome to the deep dive, everyone, because today we are stepping into a true medical mystery.
We really are. It's regarding the recent sudden emergence of anomalous white fibrous structures found inside the blood vessels of corpses.
And the diagnostic muddy waters here are coming from a very unexpected source.
Right. Our mission today is to look at a raw, startling safety signal being raised by an unlikely group of frontline workers, which is embalmers.
Yeah, we are looking at how an entirely new physical phenomenon could be, hiding in plain sight.
Exactly. And to do this, we are unpacking two distinct sources for you today.
All right, first up is a peer-reviewed paper published in July 2026 in the International Journal of Innovative Research in Medical Science.
Which was by Thomas F. Haviland and his team, analyzing a multi-year survey of embalmers.
And second, we have a commentary video by Dr. John Campbell that breaks down these findings and adds some really fascinating frontline anecdotes.
But before we even begin analyzing the data, we really should establish the parameters of this discussion.
Yes, absolutely.
We are here to look at the observational data objectively. This deep dive is about examining a timeline correlation and a physical anomaly.
Right. It is not about jumping to conclusions or, wading into the political debates that often surround medical anomalies today.
No, not at all. We are impartially reporting the data exactly as it is presented in these sources.
So, okay, let's unpack this. Let's start with the physical anomaly itself.
Good place to start.
Because to understand why seasoned professionals are sounding the alarm over these structures, we really have to understand what normal looks like.
Right, when a human body ceases to function.
Yeah, exactly. What is the baseline for a postmortem blood clot?
Well, in the scientific study of death thanatology, postmortem blood clots are incredibly well documented. There are two classic types you will see in forensic pathology literature. The first is called a chicken fat clot.
Chicken fat. That's quite a visual.
It is, yeah. When circulation stops, gravity basically takes over. The heavier red blood cells settle to the bottom of the vessels, leaving the yellowish, clear plasma pooling at the top.
Oh, I see.
And when that plasma coagulates, it forms a yellowish mass that, well, resembles chicken fat.
Okay, so that just sounds like a simple physical separation based on density.
It totally is. And the second classic type is the current jelly clot, which forms from the lower red blood cell-rich portion of that separated blood.
So that one is dark red and gelatinous, I assume?
Exactly. Now, the defining mechanical characteristic of both these traditional clots is their friability.
Friability meaning they're fragile.
Yes, they are fragile. They do not adhere strongly to the walls of the blood vessels.
Okay.
They are simply loose amalgamations of settling blood components.
They're crumbly. Like, if I could use an analogy here, traditional postmortem clots sound a bit like pulling out crumbly feta cheese.
Feta cheese, yeah.
It's soft, it breaks apart easily in your hands, and it doesn't hold any kind of structural shape once you remove it from its container.
That feta cheese visual accurately describes the lack of structural integrity in a normal clot.
Right.
Because the new structures described in these recent reports operate on completely different mechanical principles.
Yeah, embalmers are describing them as tough, rubbery, and highly elastic.
They resist tearing under tension. They are white or off-white.
And the shear scale is unprecedented, right?
Unprecedented. Some are several inches to a foot long, occasionally approaching the length of an entire limb.
I mean, Dr. Campbell's video mentioned embalmers comparing the texture to calamari or earthworms.
Yeah, that comparison to calamari speaks directly to the tensile strength of the material.
Right.
Furthermore, these structures are forming perfect, cohesive casts of the inside of the blood vessels.
So they mold to the exact shape of the vascular lumen.
Exactly. They even capture the bifurcations, which are those branches where a vein or artery splits into two smaller vessels.
So going back to the plumber analogy for the start of our deep dive, if a traditional clot is crumbly feta cheese,
Right.
these new structures act like a solid, unbroken piece of silicone caulk.
That is a perfect way to describe it.
And because they capture those bifurcations, they must be creating massive blockages.
Oh, they completely impede the normal fluid dynamics of the vascular system.
Wow.
When an embalmer attempts to flush the system to distribute preservative fluid, the pressure simply hits a wall.
Because the fluid cannot bypass these casts.
Right. The embalmers are literally forced to use forceps to physically grip these massive elastic structures and pull them out in one long piece just to clear the pathway.
I mean, seasoned practitioners pulling foot-long silicone casts out of veins is just a jarring scenario.
It really is.
But anecdotes, no matter how vivid, aren't enough to build a scientific consensus. We need to look at the numbers.
Yes, the data.
Which brings us to the Haveling study. This is a multi-year cross-sectional survey spanning from 2022 to 2025.
And the methodology here is very important. They targeted active embalmers across 5 specific countries.
That was the United States, Canada, the United Kingdom, Australia, and New Zealand, right?
Correct.
Surveying 5 countries across different continents immediately removes the excuse that this is just, a local environmental contaminant.
Or a bad batch of embalming fluid in one specific region,
Right. This is a global data set. So what was the consensus among the practitioners?
Well, across the 4 annual surveys, they gathered 808 total responses. And depending on the specific survey year, between 66% and 83% of the embalmers surveyed reported seeing these exact white fibrous structures.
Wait, up to 83%.
Up to 83%.
That is, of the professionals whose daily job is to clear the human vascular system, that is an overwhelming majority confirming the presence of these blockages.
It really is. And the survey also asked them to quantify the frequency.
Like how often they were seeing it per body.
Right. When estimating what percentage of the individual corpses they handled contained these structures, the weighted average across those survey years ranged from 19% to 27%.
So roughly a quarter of all deceased individuals passing through their care are presenting with these anomalies.
Yes.
But the timeline is the mechanism that really demands attention here, I think.
Definitely.
Because the 2022 survey asked embalmers to pinpoint when they first started observing these structures.
And the baseline data is very revealing. In 2018 and 2019, only about 14 to 17% of embalmers reported seeing anything even remotely similar.
Okay, so there's a baseline.
Right. But in 2020, first observations spiked to 37%.
Wow.
And then in 2021, that number skyrocketed to 80%.
So you have a baseline of roughly 15%, and within a 2-year window, it jumps to 80%?
Yeah.
That is a massive temporal shift.
This is a crucial juncture in the data, and it really requires strict analytical discipline.
Right. We have to be careful here.
Exactly. This dramatic rise in first observations correlates temporally with the COVID-19 pandemic era and the subsequent global vaccine rollouts.
Okay.
Both the Haviland paper and Dr. Campbell's commentary are explicit that this survey data highlights a timeline correlation.
Correlation, yeah.
It does not definitively prove causation.
Right. The timeline indicates that a major systemic shift occurred, but it doesn't give us the biological why.
Precisely. Because the paper notes multiple confounding variables. Well, SARS-CoV-2 infection is strongly associated with hypercoagulability.
Which is an increased tendency for the blood to clot.
Right. There were also massive shifts in pandemic-related mortality rates, significant changes in how long bodies were stored in refrigeration before being embalmed.
Oh, that makes sense.
And alterations in end-of-life medical protocols. So the spike in the data is a clear signal that something in the physiological environment changed.
But the survey itself cannot diagnose the specific cause.
Exactly.
Now, I need to push back on the data here, just looking at this from a skeptical perspective.
Sure.
The most obvious variable is the embalming process itself. Embalmers inject formaldehyde-based preservative fluids into the body under immense pressure.
They do.
And formaldehyde is a fixative, right? It rapidly cross-links and coagulates proteins.
Yes.
So couldn't we just be looking at a chemical reaction where the embalming fluid is flash-cooking normal blood plasma into these bizarre rubbery shapes?
That is absolutely the most logical counterargument.
Yeah.
And the Haviland paper addresses the chemistry of embalming directly.
Oh, they do? Okay.
Yeah. It is a biological fact that formaldehyde fixes existing clots in place, altering their texture and color.
Right.
However, the embalming process, the fundamental chemistry and the mechanical pressure used, has not changed in any significant way in decades.
Ah, I see. So the chemical catalysts remain constant, but the baseline of observations shifted abruptly in 2020.
Exactly.
If formaldehyde alone was causing these silicone-like casts, embalmers would have been pulling them out of arteries at the exact same rate in 1995 or 2015.
That's exactly the point. Additionally, these are highly experienced practitioners.
Right.
Embalmers routinely employ water conditioners and specific anticoagulants in their fluid mixtures.
Oh, specifically to prevent that.
Designed entirely to minimize chemical clotting during the procedure, they are intimately familiar with iatrogenic changes.
Which are the changes caused directly by their own chemical interventions.
Right. The respondents are emphatically stating that these new structures possess a tensile strength, length, and obstructive quality that is fundamentally different from anything induced by embalming fluid in their past experience.
Okay, here's where it gets really interesting to me. That completely inverts how we typically view medical authority.
How so?
Well, we assume the forensic pathologist with the scalpel and the microscope sees everything.
Right.
If up to a quarter of corpses have these massive structures blocking their veins, why are morticians the ones catching the systemic failure, while mainstream pathology seems to have a totally blind spot?
What's fascinating here is that it comes down to the fundamental differences in methodology between the two disciplines.
Okay.
Embalming is inherently a fluid dynamics problem. The goal is to distribute preservative fluid throughout the entirety of the vascular system.
Right, the whole body.
To do that, you have to utilize the body's plumbing as a continuous closed loop.
Makes sense.
So if there is a massive blockage anywhere in that system, the fluid will not flow, drainage will halt, and the embalmer is forced to hunt down the obstruction to complete their work.
So they are structurally required to find the blockages.
Exactly.
But an autopsy operates on a completely different set of mechanical goals.
Yes, a standard autopsy is a highly localized procedure.
Right.
The pathologist typically opens the body cavity, extracts specific blocks of organs, the heart, lungs, liver, brain, and then slices tiny cross-sections of tissue to examine under a microscope.
So they're looking at things on a micro level.
Exactly. They're looking for cellular anomalies, disease markers, and microscopic tissue damage. They are not attempting to flush fluid through the macrovascular system.
Okay, to explain that blind spot, it's like comparing a city planner to a municipal sewer worker.
I like that.
Right. The pathologist is the city planner taking tiny samples of tap water to test the microscopic chemical makeup.
Yes.
But the embalmer is the worker down in the sewer system trying to physically unclog a 10-foot fatberg from the main pipe.
That is exactly it.
The planner looking at the water chemistry is never going to see the massive structural blockage in the pipes because they simply aren't interacting with the system in that way.
That is an excellent way to conceptualize the methodological gap.
Thank you.
In fact, Dr. Campbell's video highlights a highly illustrative anecdote from a UK funeral director named John O'Looney that perfectly demonstrates this.
Oh, what happened there?
Well, O'Looney received a body that had already undergone a standard comprehensive post-mortem examination by a pathologist.
Okay.
The pathologist had removed the usual organ blocks, determined a cause of death, and basically finished the procedure.
So a highly trained medical doctor had already been inside the body cavity, looking specifically for anomalies.
Yes. And yet, when O'Looney prepared the body for embalming, he looked at the exposed top of the femoral artery in the leg.
Which was only visible because the pelvic block had been removed during the autopsy, right?
Exactly. Sitting right there in the open, completely missed by the pathologist, was a massive white fibrous clot.
You're kidding.
No, O'Looney had to physically extract it himself.
So the pathologist missed a major structural anomaly simply because their protocol didn't require them to look for it.
Exactly.
If your procedure involves cutting through vessels to remove organs rather than flushing them, you might look at a cross-section of a blocked vessel and assume it's just a normal localized clot.
Completely unaware that it extends for another 12 inches down the leg.
Wow. This highlights a huge potential systemic flaw in traditional pathology protocols when dealing with novel macrostructures.
Right. If the medical establishment doesn't know a macrostructure exists, they won't design protocols to look for it.
It requires someone interacting with the entire closed loop to discover the failure.
Precisely.
So we have a well-documented physical anomaly with a specific mechanical profile. We have a timeline showing a massive statistical spike.
Yes.
And we have a clear, logical explanation for why mainstream pathology has missed it.
We do.
So what does this all mean? What is the scientific mechanism for figuring out exactly what these structures are? You can't just leave a mystery like this hanging on observational data.
You can't. And the Haviland paper issues a direct scientific call to action.
Okay, good.
Survey data from embalmers serves as a crucial sentinel signal, but observational surveys cannot definitively characterize the chemical makeup of these structures.
Right?
The paper calls for rigorous, independent laboratory analysis using specific testing modalities.
So how do we get a definitive chemical fingerprint of these casts? What specific tests does the paper suggest?
Well, the first is histopathology.
Histopathology.
This involves taking thin slices of the structure, applying special chemical stains, and examining it microscopically to determine its architectural makeup.
Like, is it organized cellular tissue or is it an amorphous aggregation of proteins?
Or does it contain synthetic elements exactly?
Yeah.
The second test is proteomics.
Which is the study of proteins.
Right. It's the large-scale study of proteins. By analyzing the structure, scientists can sequence the exact proteins present.
So determining if they are standard fibrin from blood clotting, amyloid deposits, or something entirely novel that has misfolded.
Exactly. And the third test mentioned is Raman spectroscopy.
Raman spectroscopy.
Yes, Raman spectroscopy is, it's fascinating because it relies on the interaction of light and chemical bonds.
How did that work?
You shine a specialized laser at the sample. The light interacts with the molecular vibrations of the substance, causing the photons to scatter.
Okay.
By measuring that scattered light, you generate a highly specific, definitive chemical fingerprint of the material.
Leaving no room for ambiguity about what the substance is made of.
Exactly.
Well, have any independent laboratories actually started applying these mechanisms to these structures, or is the academic world just keeping its distance?
There is early movement, thankfully. Dr. Campbell references a preliminary report out of New Zealand that has begun this type of chemical breakdown.
Oh, that's promising. What did they find?
Their initial findings indicate that these white fibrous structures do contain abnormal proteins, alongside certain clotting factors you would normally find in blood plasma.
Wait, really?
Yeah.
So they aren't just regular clotted blood, but they do contain elements derived from human plasma mixed with abnormal protein aggregations.
That's what the early data suggests.
That necessitates massive, well-funded replication to confirm.
It absolutely does.
And if we are analyzing this impartially, we also have to look at the limitations of the Haviland study itself.
Yes, any rigorous scientific deep dive must acknowledge methodological limitations.
Right.
The Haviland study relies entirely on non-probability sampling. This introduces a very real statistical risk of selection bias.
Because the embalmers opting into the survey are self-selecting.
Exactly.
I mean, if you are an embalmer who has been pulling terrifying foot-long rubber casts out of bodies for 2 years, you are highly motivated to fill out a survey about weird vascular anomalies.
You definitely are.
But an embalmer who hasn't noticed anything unusual might just ignore the email entirely.
And that selection bias skews the prevalence data. Additionally, there is no standardized biochemical confirmation for the 808 responses.
Right. The study relies entirely on the visual assessment of the respondents.
While experienced embalmers are highly skilled observers of postmortem changes, human observation without laboratory confirmation is always subject to variability and error.
And that selection bias and lack of formalized laboratory backing is exactly why observational data like this gets hijacked.
Oh, definitely.
When mainstream science leaves an informational void, the internet rapidly fills it with noise.
It does.
Dr. Campbell actually had to end his commentary video by addressing this exact phenomenon, didn't he?
He did. He issued a stark warning to his viewers about AI deepfakes.
Oh, man.
Highly realistic, artificially generated videos of Dr. Campbell are currently circulating online.
That is so crazy.
Bad actors are using his likeness and the authority he has built discussing medical anomalies to sell dubious, fake medical cures.
Consider how terrifying that is for the state of medical research.
It's extremely concerning.
You have frontline workers waving a massive red flag about calamari-like structures blocking human veins. But they are trying to be heard in an information ecosystem dominated by algorithmic echo chambers, hyperpolarization, and literal AI deepfakes, weaponizing the medical mystery for profit.
It perfectly illustrates why peer-reviewed, systematic data collection, like the Haviland paper, is absolutely vital.
Right.
Without a structured, methodical approach to cataloging these anomalies, the real scientific signals get completely drowned out by the noise of internet rumors and bad actors.
Which brings us back to why you should care about this, even if you never plan on setting foot inside a mortuary.
Yes. If we connect this to the bigger picture, This entire deep dive is a masterclass in the sheer value of frontline observational data.
I couldn't agree more.
We have spent the last few decades idolizing the sterile, high-tech laboratory as the exclusive domain of true medical discovery.
Yeah, we assume that if something important happens in the human body, a supercomputer or an MRI machine will catch it first.
But this phenomenon reminds us that sometimes the most vital scientific signals come from the practitioners who are getting their hands dirty in the physical reality of the world.
The municipal workers clearing the plumbing.
Exactly.
They aren't publishing theoretical models. They are dealing with the undeniable physical reality of fluid dynamics and blocked vessels on a daily basis.
Right.
And when 800 of them report a massive systemic change, dismissing it because it doesn't fit neatly into our current textbooks is a failure of the scientific method.
Knowledge is only valuable when we possess the intellectual courage to explore the anomalies.
Yes.
We owe it to the scientific process to rigorously investigate these physical structures using proteomics and spectroscopy without prejudice or preconceived conclusions.
It is a profound lesson in intellectual humility.
It really is.
We assume we have the human body completely mapped, quantified, and understood, but biological systems are always capable of generating entirely novel errors. Which brings me to a final thought I want to leave you with today. Think back to that X-ray analogy we discussed earlier.
The comfort of the visible, clean, easily categorized medical world.
Right. The expectation that every anomaly have an immediate textbook explanation.
But today we explored how funeral directors, the professionals operating at the very end of the medical line, are discovering massive foot-long structures in the human body's plumbing that the world's top pathologists simply didn't see.
So the question to mull over is this. What other major system-wide biological changes might be hiding in plain sight right now, simply because our highly specialized experts are using the wrong lens to look for them?
A deeply unsettling but absolutely necessary scientific question.
It fundamentally changes how you view the limitations of medical expertise. Thank you for joining us on this deep dive. Stay curious, keep analyzing the data, and we will catch you on the next one. Take care.